This is Mr. Hassan's Maths channel, and I'm now answering a question from this paper, this Pure Mathematics 3 paper, paper 3, variant 3, from Cambridge 9709, October, November 2022. So I'm going to answer, in fact, I'm going to go through this whole paper, but not in one video, in separate videos. And this is a paper I set for my students as like a mock exam. And I'm answering each question after having marked all the papers of that question, all the students work on that particular question. So I'm going to do that. I'm going to mark a question, note all the kind of mistakes that students were making and important points that I think they need to learn from those mistakes, and then I'm going to mark the next question and then make. So the videos will all be separate videos saved under the playlist for this paper and also for the topic from which the question has come from. So I'm going to start with question number 1. So here we're asked to solve the equation ln of 2x minus 1 equals 2 times ln of x plus 1 minus ln of x. Now this question led to quite a few places where some students obviously have not looked at this topic properly, they have not revised it properly, and they were doing some really strange things as if they've never seen such a thing before, as if some sort of an alien to them. Okay, now in Cambridge, logarithms are introduced in the second year of A level in P3, not in P1, whereas in Excel they're introduced at the AS level in the P2 exam. But something which students have to really work on. Okay, so I have made a video on the basics of logarithms, okay, which there will be a card here appearing during this video on the top here, which you'll see. You can click on it, it'll take you to that. It goes into some detail, but I'm going to try and also go into a bit of detail in this particular video to make sure that we clarify some of these misconceptions. Okay, so basically ln is a type of log. It basically means log to the base e. Okay, so the ln of x, for example, will be log to the base e of x. Okay, that's what it means. Okay, it's written in this form, but that's what it means, log to the base e of x. Okay, so if we have a logarithm, so for example, we have log to the base a of b equals c. It's just another way of writing something alternative to index form. In fact, it's the inverse of the exponential function. So if you wrote this in normal form, a would be your base, c would be your power, and b would be your answer. So this is how you can write something in index form and how you can write the equivalent thing in logarithm form. And there are certain rules of logarithms that we have to apply, okay, that we need to know. And there's 3 basic rules of logarithms. And as I said, the video that I made above, linked above, goes through them in a bit more detail. But one of the rules we need to know, okay, is you can call it the addition or the multiplication law. I'll call it the addition law. And it's basically based upon the laws of indices. Okay, for the addition law is when you have log to the base a of b, or let's say p, plus log to the base a of q, you can write this as log to the base a of the product of p times q. All right, that's the addition law. All right, so that's something that we have to know. And secondly, we have what's called the division law, or we can say subtraction law, keep it consistent. It's called the division or the subtraction law. Again, it's kind of based upon laws of logarithms. So the subtraction law, okay, is when you have log to the base a of p minus log to the base a of q. It's the same as having log to the base a of p divided by q. All right, that's called the subtraction law. And then you also have what's called the power law. The power law. Okay, so the power law, for example, if you have log to the base a of b to the power of, say, x, this can be rewritten as x times log to the base a of b. All right, you have something like this. That power can be written as a coefficient and vice versa. So it's important for us to know how we can combine logarithms, how we can split them up, okay, and how we can simplify them, okay. And a few points, for example, if I have, for example, log to the base a of x plus, say, z times log to the base a of y, I can't use a multiplication law on this until this has been written as a power there. Okay, you got to get rid of the multiples. So this is log to the base a of x plus log to the base a of y to the power of z. Now I can use the multiplication law. So log to the base a of x times y to the power of z. Okay, so you got to get rid of these multiples first by writing them as powers before you can use, for example, the subtraction, or in this case, the addition law. Okay, so that's like a little side point here after the power law. So it's very important for us to know these rules, okay, where they come from. Well, if you watch the video that I've linked above, and I'll link it also in the description, you should be able, I go through a bit more detail about where these laws come from and, you know, some background behind them. Okay, but those are 3 essential laws that you need to know when we are solving questions dealing with logarithms. You have to understand how they work, all right? And, you know, very, very important for us to know. If you know, for example, if you say log to the base a, and you stop there, it doesn't make any sense. It has to be log to the base a of something. Something must be there. It means a to the power of something equals this thing. You can't just say log a or log. It has to be, there has to be a number here. Okay, log to the base a of something. That actually gives it a meaning. All right, so now what I'm going to do, I'm going to cross all of this off, and we're going to actually go through the question now with some of that background information that we need to know. Okay, so again, I'm not doing this video as a walkthrough for people just to you know, see the answers. I'm doing it as a teaching tool for my students who took the mock exams, and some of them, they need to watch this. Okay, so now ln of 2x minus 1. As I said, ln is just the ln of x, means the log to the base e of x. It's just written in this form. The number e is sometimes called the natural number, so it's log to the base of the natural number of x. It's just the way that we write this. There's not something, you know, really strange apart from that. That's all it means. Okay, so nothing to be worried about there. Now, so we want to solve this equation. I want to solve this log equation. So I'm going to go through some of the things that people did, okay, which make absolutely no sense. Okay, now some of them, they think of this as if it was like, for example, y times 2x minus 1, and, you know, 2y times x plus 1. And they were like saying, okay, y times 2x is 2xy, and y times minus 1 is minus y. Ln by itself means absolutely nothing. Just log to the base e. It's like there's something missing. Log to the base e of what? This means log to the base e of 2x minus 1. You can't say that you can multiply this bracket out. That's completely nonsense. So the students who did that, obviously they haven't done, you know, an iota of revision. They probably didn't even come to the class. We went through it. Right, so it's very important that you don't make those kind of silly mistakes. Right, ln by itself does have absolutely no meaning. Okay, it's like saying, you know, the sine of x plus 30. All right, it's like it's sine times x. No, it's not sine times x. It can't be sine x plus sine 30. No, you don't multiply this sine by this. This is a sine of this whole angle. The angle here has, you know, a meaning. It's like this is the sine. This is the input of the sine function. And to split it up, we've learned the addition formula and stuff like that for sine. Similar kind of thing with ln. You can't just write ln by itself. It's not ln times 2x. Okay, that's one thing that students were doing. Second thing that students were doing, they were thinking, oh, there's ln on all of these, so let's get rid of the ln. Let's just cross out the ln. And they wrote 2x minus 1 equals 2 times x plus 1 equals x. And that's wrong. You can't do that. Okay? If you have the ln of something on one side, if you end up with if in the end you end up with the ln of a equals the ln of B, then A equals B, right? They have to be one ln term, okay? Some people think of it, okay, we can raise this to the power of E. And that kind of is okay, that's fine, you can think of it like that if you want, but it should be one term, okay? It should be one term, not multiple terms like that, okay? And another thing that people did is they said ln of 2x minus 1 equals, they said 2, and they put ln of x plus 1 over x, and then they put this all squared. All right, and that again is wrong because we cannot combine these two. We cannot combine these two until you've got rid of this power. So it should be, you should raise the power first and then combine them. With a multiple there, it cannot be combined. This is wrong. Right, that's another thing that some students were doing in their steps. So something you have to be very careful of. So to solve this problem properly, we have the ln of 2x minus 1, I'll leave that for now, equals, so we'll have the ln of x plus 1 squared minus the ln of x. That's step 1. Now I'm going to combine these two together using the subtraction law. So this side stays as a ln of 2x minus 1 equals, and now I've got the ln of, I have x plus 1 squared over x. The ln of all of that. Okay, now we have the ln of something is equal to the ln of something, one term on each side. Now I can say 2x minus 1 is equal to x plus 1 squared over x. All right, now that's, you know, absolutely, this is perfectly fine. Now it's perfectly fine. We can continue from this. We've got rid of the ln. Now we can solve the equation, right? There are a few alternative things that people could do, which I saw that some people did. Like, for example, I saw some people do this. They wrote the ln of 2x minus 1 over x plus 1 squared equals the ln of x. Okay. What did they do? Sorry. Equals minus ln x. And some people did this. They put minus ln x. And then what they did was, and this is not okay, they then got rid of the ln and they put this as minus x. No, that is a multiple multiplying the ln x. You cannot, just get rid of the ln now and think it's going to be equal to minus x. This is going to be, this minus is going to become ln of x to the power of minus 1, which is ln of 1 over x. Then we can say this is equal to 1 over x, which will give us basically the same thing as this, because you'd have 2x minus 1 over x plus 1 squared equals 1 over x, which will be the same thing as this. If you rearrange it, it will give you the same thing as this. Okay, that's fine. So you can't leave the minus sign there and then get rid of the ln. Okay, you have to get rid of this. This is like minus 1 times. You have to apply the power law first, and then the ln of something equals the ln of something else. All right, the minus sign must be got rid of as well. That's another point that some students made mistakes with. So I'm trying to remember all the problems, all the issues that students had. Another way you could do this, some people did this, they said the ln of 2x minus 1 minus the ln of x plus 1 squared plus ln of x equals 0. And then they combine this all onto one side. So they said the ln of, they had x times 2x minus 1 over x plus 1 all squared equals 0. And then they use the fact of the meaning of logarithms. This means e to the power of 0 is equal to whatever's in here. X times 2x minus 1 over x plus 1 squared equals e to the power of 0. Now, e to the power of 0 is the same as 1. And then you get exactly the same thing that we got before. That's perfectly fine as well. Okay, so there's a few ways you can do this. I personally think the way that I did it is probably the easiest way. All right, and now we can go on to solve the equation. And the other thing we must note, very important, that the questions, I advise you to read the whole question in the beginning before you start, the whole question. Don't just read the solve your equation bit, right? Some people read this bit and they think, okay, let's go ahead and do it. And they give the answer, and then they don't remember about what it says at the end of it. Haven't looked at it. Give your answer correct to 3 decimal places. All right. So some people actually in the end they wrote their answers incorrect in exact form, and they lost a mark for that because it says clearly to 3 decimal places. So anyway, let's go on to solve this. We can multiply both sides by x. So you have x times 2x minus 1 equals x plus 1 squared. So of course we have a quadratic equation now. So we can expand the brackets. 2x squared minus x equals x squared. You multiply them and double it, plus 2x plus 1. We can bring the x squareds, all the terms on one side, as is a quadratic. We're going to use the zero product property to solve it. So 2x squared minus x squared is x squared. Minus x minus 2x is minus 3x. And you got minus 1 equals 0. So now this cannot be factorized. Okay. That's quite obvious from the question. So we have to use the quadratic formula, or we can use completing the square. Either is fine. I'm going to complete the square. So x squared minus 3x equals 1. So you have x minus 3 over 2 squared minus 9 over 4 equals 1. So x minus 3 over 2 squared is equal to, this is 4 over 4 plus 9 over 4. That's 13 over 4. So you have x minus 3 over 2 squared is equal to plus or minus the square root of 13 over 2. Right? Because you're going to take the square root of 13 over 4. You got plus or minus. Don't forget plus or minus. Okay, both answers should be at this stage there. Okay. And then you can, so that's x plus x minus 3, sorry. After we've taken the square root, we don't have the square sign on this side, of course. So you have x minus 3 over 2 equals, you have x minus 3 over 2 is equal to plus or minus root 13 over 2. So x is equal to 3 over 2 plus root 13 over 2, or 3 over 2 minus root 13 over 2. So this is 3 plus root 13 over 2 and 3 minus root 13 over 2. So we can work out what our answer is. Okay, if you want to make sure that you haven't done something silly, we can use the quadratic formula even at this stage, just to make sure. So we can put minus b, so minus 1, so that's going to be 3, plus or minus the square root of, so plus first, the square root of b squared, that's going to be 9, minus 4 times 1 times 1, 4 times 1 times minus 1, so it's going to become plus 4, okay, over 2a, which is 2. So you have 3 plus root 13 over 2 and 3 minus root 32. Okay, so this gives us what? This gives us 3.3027. 3.3027 continues. That's one answer. And the other answer we're going to get from the calculator is, if I put a minus between them, that gives me 0.3. It's the same value, except actually it's not the same. It's negative 0.3027. Negative 3.0277. Just make sure it goes on like that. Okay, so those are the two answers. Now, the question here says, give your answer correct to 3 decimal places. Here we have 2 answers that come out from my equation. So that should ring a bell for you. That's why it's important to read the question carefully. Secondly, we should know with logarithms that the log function, the log of anything, right, will always have to have an input which is positive, otherwise undefined. Because any log graph looks something like this. It never ever even becomes, x can not even be 0, right? The input has to be greater than 0. Okay, so if the input of any of these ends up becoming negative, then that value has to be rejected. And we can see that they have ln of x, and one of the values of x from this equation is negative 0.30277. So we have to reject this answer. We say only, and we should make it clear that we're only writing x equals 3.0. And now it said to write the answer to 3 decimal places. So 0, 2, 3.303. 3.303. Third decimal place is here. Okay, so this is the only answer. We reject the other answer, which is negative. All right, so that's how you go about solving question number 1. Okay, so there's a very important points here that you have to take into consideration. If you have not revised logarithms properly, you must revise it. Okay, so there's the answer to question number 1 from this paper. I hope that was clear. Other questions from this particular paper will be found in the playlist that will appear in the top right of this screen at the end of the video. Other questions dealing with logarithms from P3 of Cambridge can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and I'm going to in fact link the video which goes through the basics of logarithms in a bit more detail. Okay, I'm linked that video over here, so those who want to refer to that can do so. Thank you for watching, and see you soon.